58.19 millimeters.
So I'll basically be able to monitor these until I leave.
Okay.
And if they're going to die, they're going to die soon. But
Yeah.
if they're still alive by the time I leave, then that gives us a whole month of them just sitting in the lake.
Before we can introduce mussels into the lake, we wanted to run a survival pilot study. So we put a floating cage, it floats about 2 to 3 feet underwater. We put that in to keep the mussels in and also to keep things like crayfish out. And regular monitoring of both their growth and survival is indicating that they're going to survive well in this lake and they're going to grow. There's enough free-floating algae that they're going to be able to filter out and consume and grow from that. And in addition, the water chemistry of the lake is suitable to support growth. So they actually require different minerals for their shell growth.
But also what we're trying to do is these are not brooding right now, so they're not pregnant, but we really need pregnant females. So the idea is to hold them in the lake, give them some time to start naturally brooding, and once that occurs, we're going to ship them off to Missouri State to Dr. Chris Barnhart.
Chris Barnhart is a leading expert on freshwater mussel conservation and propagation in the lab. And his role in the project is looking at Anodonta californiensis, the freshwater mussel that we want to reintroduce, and how we can rear these animals in the lab by the thousands and thousands and get them into the lake established at very high initial numbers to kickstart the population in the lake.
These came from Pajaro River, which is the border of Santa Cruz County and Monterey County.
It's sort of a really interesting portion of the project because this species of mussel is becoming quite rare throughout its range on the West Coast. Freshwater mussels are on the decline globally because of the impacts to water quality from agriculture, pesticide use, herbicide use, sedimentation, and all of these synthetic chemicals. So freshwater mussels, i.e. filter feeders, their improvement towards water quality doesn't improve sedimentation and stuff like that, but it does improve algae in the water because they consume that.
I started working with this mussel when I started to think about, okay, well, how can we use the power of nature to improve our water quality? And realizing that mussels have this unique ability to filter particulate matter. But I wanted to take it a step further and say, okay, well, there's a lot of times these personal care products and pharmaceuticals that enter our waterways and also high levels of bacteria. And can these mussels actually help remove that? And that's how I started studying them. And then I eventually noticed that, yes, they do indeed make a significant reduction for a lot of these chemicals, as well as especially with bacteria. And I started to think, well, how exactly could we use these out in the field and take it outside of the lab, which is where Mountain Lake came into play. Talking to John, we started thinking, well, wouldn't it be neat if we could do some sort of initial demonstration project? And, if we put them into Mountain Lake, what can we actually quantify with regards to water quality improvement? And while we already knew that algae was going to be one thing that they eat, I wanted to look into something a little bit different that people haven't studied and documented in large details, and that's why I looked at bacteria. And then seeing that the loads in Mountain Lake of bacteria were really high, I was like, oh, this is a good thing to study. So a lot of times people think of E. coli as being in food poisoning. What it actually is really good indicator of is levels of fecal pollution in the water. So because if you've been to Mountain Lake, there's a lot of birds and dogs in the area, they could be contributing to this loads of bacteria. And looking at the mussels when they're exposed to Mountain Lake water, they actually do a really good job of removing the bacteria. So over like a 1-day time period, there's a 10 times reduction in the bacteria levels. And then they maintain that level throughout the time period that they were exposed to Mountain Lake water. And the experiment I did was just for 30 days. We're hoping that once we reintroduce them to Mountain Lake, we'll see a nice decrease in the levels of bacteria in the lake.
So this project, tying these mussels into Mountain Lake, is sort of both from a conservation perspective, trying to not only just understand these mussels a little better to apply outside of Mountain Lake, but also establishing a very healthy population within Mountain Lake that could be a reservoir of this species in case other projects down the road need a source of these mussels to use. And then in addition to that, they're filter feeding. They will actually take in and deactivate it in E. coli. What they do is they pump it back into the benthic environment, which is actually a very important link in the food chain between free-floating algae and the invertebrates that use the mud in the sediment. So there's sort of a connection between that link in the food chain, and then it has to work its way through the system. And that's just one link of probably many complex links that we're not aware of yet that these mussels have, and the whole system of Mountain Lake is that we're trying to establish to bring back these natural checks and balances of these native species that have relationships that have evolved over thousands and thousands of years. Very complicated, very complex, lots of things we don't even know about yet.
Oh, it's really great. It's really good.